morning. Thanks everyone for joining. Today, I'm honored to be joined by Tony Sukhwani of Belkin. He's going to be walking us through a plugin that he has developed for Cameo Systems Modeler that incorporates artificial intelligence. So Tony, I may turn it over to you. We're all excited to see what you've done here and how you've incorporated AI into Cameo Systems Modeler via a plugin. So thanks again for joining, Tony, and we're happy to see what you have.
Thank you, Brian. Appreciate it. So we built this plugin here to assist modelers with the drudgery of just like creating all the elements and all the relationships and basically automating the tasks to enable our modelers to do the critical thinking as opposed to focusing on just the mechanics of modeling itself. So what you see on the right side of the screen here is our plugin. It's called BAM, Belkin AI Assisted MBSE. We can, very similar to your ChatGPT, the UI has a area to prompt, and then we get our response down there. Additionally, the responses will come up in the form of model elements and diagrams if we ask it to build something. Generically, we can just ask a question like, what is MBSE?
Okay.
So we do that, pretty quick to get the results, and we get our answer on what is MBSE. The one thing we have purposely built in this is that everything is one shot. So we do not have history here for a good reason, especially when it comes to building models. If one thing you get back is wrong, such as a requirement, there is a downstream impact of everything following that. We can get started with the plugin. So the way this works is we are sending in our prompt. For example, I have a prompt I'm going to build some packages. So build me packages for a system model and compliant with MagicDraw. So we're doing that. So the way this works is I'm sending in the prompt. The keyword here is build, so it knows to build me something. And then I'm actually sending in I'm actually doing a prompt on my prompt, trying to figure out what I'm, contextually what I'm trying to do. So build me packages. So it picks up on that. So there's specific code in the plugin to know that we're going to build packages, to go into a special mode to build some packages.
Okay.
And the associated diagram. So this is a package diagram. While this isn't exactly what the magic grid looks like, we can just undo that and start again.
Okay.
So with, 3 levels of packages, I'm adding to the prompt.
Okay. So while that's doing that, is this reaching out to the Open API for OpenAI?
Not OpenAI. So this is a private Azure instance on Microsoft's backend. So this does not go out and reach the public API that a lot of people use. So this is private. None of the data is shared outside of my specific instance.
Gotcha. That's good to know.
So it has kind of made some level of package structure here. Still not great, but it's close to the correct answer. But again, in general, time saver, because how long would it take to build these packages, Brian?
Sure, yeah, that looks great. I mean, it would take time,
Right, and then we can do a little bit more. Prefix the packages with number with dot notation. I'm gonna just delete that and start again. And there we go.
Oh, that's great.
Yep, it's kind of done a better job at figuring it out. Unfortunately, for those who know MagicDraw, this has only given us effectively the first row, which is fine. Part of the second row in here as well. So now, thinking of the general workflow, what do we do in terms of system engineering? We have our package structure, and now we need some stakeholder needs.
Right.
So I'm going to take those out because this is good enough for now. And so we want to populate our stakeholder needs. So then we say, build me a set of requirements, treat them as stakeholder needs, prefix the ID with sh dash, and pretend I don't know how to write a requirement. Much like our stakeholder needs.
So the fact that you highlighted stakeholder needs, does that tell it where to put those requirements?
No, I purposely create a new package for everything that's generated. So this way, there is a human in the loop. So everything is put in its own package, and we have our own stakeholder needs. Unfortunately, I didn't specify what the system is. So it just made some generic stuff.
Sure.
So I'm going to delete that and go back.
Okay.
What kind of system would you like to build, Brian?
Oh, let's say, how about an electric vehicle?
Electric vehicle. There we go. Here are our requirements for an electric vehicle.
Very nice.
So the point is, we see these and we can go in and modify. We should be able to go in and modify. So this way, if our stakeholder needs are correctly captured, the derived requirements will be correctly captured, the use cases will be correctly captured. So the whole point behind this workflow is to see what we have, make changes, and then we can continue building from here. So let's say we need a minimum range of 300 miles. That seems a bit sporty these days. So let's go 200 miles, charge from 0 to 80 in less than 30 minutes. Sure. So these are fine. I won't go into too much modification, but now we can go and I'm going to go ahead and make a new package in here, 1.1.3 stakeholder needs. And I don't necessarily need this diagram or this anymore because we have it all. And I'll just go ahead and preemptively make a requirements table in here to show that we can automatically do some of the traceability. So we have our stakeholder needs, and then from here, next step is generally use case identification. So we can do that from our stakeholder needs, build me a set of use cases for an electric vehicle using these selected elements. So that's my trigger to pull in from the model. So what I'm doing, go ahead, Ryan.
No, sorry to interrupt. Yeah, so it's able to recognize that you highlighted those requirements?
Yeah, so I have a trigger. So with this specific string of using these selected elements to take what I highlighted and convert it, we're converting it into JSON. So ID, name, text in this case, and feeding that back in to go ahead and create the specific associated relationships. So I'll go ahead and build that, and we're going to see some use cases, some actors, and the associations between those actors. And what we also have in the background is the narrative of the use case, which we'll see in a moment.
Okay. Yeah, that's fantastic, Tony. I'm impressed. So you said it's going to produce a narrative as well?
Yes. Wow. Yes. Here, I'll just go ahead and display all the related elements. So we're looking for well, we don't want to show the refine here, but all the associations. And we have the narrative. So the goal of the use case, although it doesn't have a solid understanding, I need to do better on the backend training of my instruction set, because it kind of almost makes a one-to-one relationship between a use case and a stakeholder need, as opposed to doing any combining. But you can see for every one of these use cases, we have the narrative, the goal of the use case, the preconditions, postconditions, primary actors, secondary actors, and the basic flow of events, and then the trigger, which I believe are all the same things that are part of the additional use case profile on the back end. I just don't particularly want to use that profile. I could, but I don't want to. So from here, we have our system level use cases, which from here we can go ahead and derive our high level activities and then derive some additional requirements from. So just to show what I didn't show is we have our stakeholder needs, and we'll just scope it. So these are our same requirements. Could also show the automatic traceability that it does. So these would be refined by here. So as you see, I didn't ask for relationships, but I have a set of instructions for if you see this element and you're making this element, make those relationships, because that's basically assumed. So we're taking away a lot of the monotony of modeling.
Great.
And we're doing a little bit of those, interesting things where we're adding we're adding the stakeholder to the requirement ID and so on. So again, this is all just building and building. If I wanted to build a set of use cases without the requirements, I could too. These use cases, not my favorite, but with a little bit of rewording, it would be it's very feasible.
Question for you. As far as when you prompt it, you're mentioning, there are some things on the back end that it's being clued in on or triggered by. So would you consider that somewhat of the customization of the GPT as far as what you also bake into those prompts and how it uses some of those strings of text to know exactly what it should be doing?
Yeah. So for example, I'll say build. So that goes into a specific mode in the code to build and then a second trigger to look for additional elements I want to pass in. So that's just purely in the code. And that also specifies what version of GPT and what type of API I'm using on the back end. This is what's using the completions API for OpenAI. And then if I say something like from your files, that uses the Assistant API, which was able to retrieve information on the files I have that I've uploaded to the backend. Right now, I just have MIL standard 704F. Not necessarily useful for this application, so I won't be going into it in great detail. And then contextually, I'm prompting for what I'm asking for here. So I'm prompting and I get a keyword back for use cases. So that goes into a specific set of instructions for SysML use cases.
Okay.
And the associated relationships a use case should have, especially going back to like requirements. Did that answer your question?
Yeah, it did. I think I would definitely consider that a custom GPT of sorts, the way that you're basing it on a simple set of instructions, but then there's more on the back end that tells it what it should be doing based on that. So I would consider that a custom GPT, and that's awesome. A follow-up question I have for that is, are you building somewhat of a glossary of these keywords that are needed in order to prompt it to do these things, or some type of documentation? I assume is a ongoing list of function calls essentially that you're using with these strings of text that it triggers based off of.
Yeah, so when this is all done, so this is still in somewhat development, this UI will be updated with a drop down to say, what do you want to do? What types of elements do you want to build? And then whether you want to import kind of a guide to make it a little bit easier.
Sure.
That'll be the intent. So some additional capability. So we have our use cases. I like what we have here. We've also identified some of our stakeholders. So we're just going to, for the purposes of today, we're going to assume these are our stakeholders. So stakeholder identification, I guess stakeholder concerns would have been the stakeholder needs. I'll just get rid of that for now. And we have use cases. We'll just put them up here. So we have our very high level analysis. So this is also great for people who don't know how to model.
Right.
So they would have a very easy time coming in here and building out at least the very high level system model with some help from modelers or SMEs to refine everything. So we'll go to activities and then we'll get into the architecture side. So let's say we want to build an activity for accelerate to 60 miles per hour in 6 seconds. We'll just go ahead with this one. Build me a set of activities for electric vehicle using these selected elements. Really, the hardest part about this is displaying everything. Right. So it has made the high level activity, which we don't need. And it somewhat makes up some of the logic. But I think what we're doing is
somewhat of a loop.
It doesn't understand the appropriate looping mechanism. So clearly that should go there. And then we need it needs a merge and a decision. So that would be more appropriate. So yeah, it was close. Yeah, again, there is, at least on my end, some expectation that this kind of stuff needs to have human eyes on it after the fact. My favorite thing, it has gone ahead and done call behavior actions so that we can populate these additional things later. It does understand the concept of a guard and a condition. I have not gone and made it so we can build object flows yet. That's very short on the to-do list. So now that we have this activity, we like it. It looks fine. So we can go ahead and give it to our use case if we want to do that. And then we can rename it, accelerate to 60, something like that.
Okay.
So the next parts of early system analysis is our block structure. We can say, build me a set of blocks for the system context of an electric vehicle.
There you go.
So it built the electric vehicle system, not exactly what I wanted, but good enough. It has the external entities associated with this. Clearly, there are more. There's regulatory and all that, but it has effectively given me the full system structure for this system without much context.
Okay.
We like the blocks. We're good with this. So we're just going to go put this in our logical architecture. And then there we can divvy out the external entities. And then one fun little thing, build me a set of value types for an electric vehicle.
Would it be value properties?
My keyword is value types. It should be value properties.
Okay, gotcha.
And if you pay close attention down here, you see I have a specific string that it's working with.
Okay.
So you won't see anything on this diagram because everything is put on the blocks, but we have developed a set of value types based on the elements. It's not super exhaustive, but it does go ahead and make some of these. And usually it'll say some of them are integers, but this time it decided not to. So there is some difference in what it decides to make.
Okay, that's awesome.
Yeah, I can also say build more. So again, what I'm doing is passing these in. It knows to also pass in the value types, ports, and other things.
Okay. This is great. So a question I have is, we've seen the activities now. Is it capable of doing anything with state machines or sequence diagrams, or is that in the plans?
We can do state machine. We have the electric vehicle block. Build me a state machine for an electric vehicle.
Okay.
Notice I'm not passing anything in because it's still generically building a state machine.
Right.
Or it's still generically building at the top level. So there we have it. We have a state machine with states that make sense and transitions that make sense.
Yeah. So did Cameo create the signals for those transitions as well? It looks like it may have.
I tell it to make the signals as well.
Okay, gotcha.
Yeah, so we have that. We have the state. We have our state machine, the regions, and all the triggers. I'm still working on the more detailed deep dive into state machines with regions and substates and parallel actions. And if there was a necessity, I have seen this using junctions and choices before. And then same with the activity diagram. It has the capability to build the forks and the joins, and as you saw, the decision node. There just needs to be a little more refinement of my instruction on the back end. Yeah, so we have state machines, and then we can ask it for kind of more abstract information. So build me a set of signals for an electric vehicle system using these selected elements. So right now, I think we can go through the building blocks of creating interfaces. So we have a set of signals, and the general workflow is we need signals, then we need interface blocks, then we need ports, and then connectors, right?
Right. Yep.
So build me a set of interface block for an electric vehicle. I don't need to put an electric vehicle. I'm just doing it for consistency using these selected elements. And then in general, interfaces are one of these things that are very confusing. There's so much detail that has to go in behind them. So having something like this to do a lot of the work definitely would help a lot of people out.
Sure, that's a great starting point for sure.
So we've made interface blocks. We have flow properties, which are typed by our signals. And so what it's doing, I have it set this way specifically where this interface block will type both ends.
Okay.
Right now they're purposely set to in out because it's a lot of thought process to figure out which way everything should go.
Right.
So now we have interface blocks, signals, and now we need ports, right?
Right. Yep.
So we'll select all these things.
Okay, so you're highlighting the interface blocks as well.
Yeah, I need to know to pass those back in. In this case, they're in name. It's really the name that matters. So contextually, GPT understands these names and that it's going to connect, it's going to build ports for these blocks. Build me a set of ports. And so right now it's set to default to proxy ports for an electric vehicle using the selected elements. Clearly, nothing to show on this diagram immediately. So we can go back to our diagram here or look in the containment tree. We have some ports created and they're directed ports to their specific endpoints. So electric motor to electric power electronics, whatever that system is. Oh yeah, the power electronics subsystem. So it's creating all that. Now we had signals. We made interface blocks. We made ports. Now we need to build out a set of connectors. So build me a set of interfaces for an electric vehicle using these selected elements.
So when it creates the connectors, is it automatically connecting those to the ports?
It is, because you cannot have you can have a connector. But as you see, we've made the connectors. Oh, they're on the main block, so the electric vehicle. So it's made the connectors right there. Wow. So let's look at the IBD. Grid diagram, internal block diagram. We'll just go ahead and do all. So it has gone, not the prettiest, but it's here.
Yeah, that's neat though that it was able to do all that.
Yeah, so it has
Oh, that's
gone.
cool. Yeah, it went ahead and made all those connectors between your ports.
Right,
It looks like
right.
they're all associated with those ports are typed by the proper interface blocks and all the connectors are there. That's awesome.
Yeah, the GPT has been pretty solid at making these connectors. I'll have to go back and check since we didn't ask for additional part properties, but I guess it figured out to make additional part properties for us.
Mhm.
Oh, there's multiple wheels, I guess. Or I did a bad copy and paste. Yeah, so overall, this is pretty solid.
Yeah, that's really neat, Tony.
And
Very
then
impressive.
we'll say, build me a set of requirements for an electric vehicle. Give me at least 15 requirements. Prefix the ID with SysML. It's doing its job, getting lots of good info. We have our requirements, and so a lot of the time we'll need some sort of glossary. So what we can do is using the terms. So we can say build me terms, elements, and add additional terms for an electric vehicle that I may need. So what we're doing is passing those requirements in, all the text, and we're building a glossary. Got all that. It did not give me definitions. We're going to redo that. Include the definition. There we go. Now we can see the definition. So then over here, we can create our glossary. Yeah, so there we go. We have all our definitions we could possibly need. I'm not sure if it made any extra, but that's a really cool feature. And then what we can do is, let's say we have a requirement for battery capacity. The electric vehicle should have a battery capacity of at least 75 kilowatt hours. So what we can do here is actually, let's see, build a test case using these selected points. So right now, what happened is I passed in the requirement, and now it's going to build us a series of steps in order to test this out. They're a little lacking, but it's a good first start. Clearly, this is a binary thing. The battery either has 75 kilowatt hours or it doesn't. But what it's doing, it's going to create the activity diagram. Yeah, so really, it's giving us the basic steps on how we could possibly test this requirement. Definitely in the future, I'm going to be what I want to do is pass in all the requirements and have it create clusters of test cases as opposed to a test case for each individual requirement. So that's one feature addition. And then what else is pretty cool is, let's say we have our requirements and we want to decompose down to the next level. But first, let's make a system structure for our electric vehicle again. So build me blocks for an electric vehicle using these selected elements. So what I'm going to do is pass in these requirements. It will create the blocks and also create the satisfy relationships between the blocks and these requirements. Although I know, with SysML, we could specify further, whether it's functional, performance, etc., to either trace specifically to value properties or any of that stuff. We're just doing, basic normative SysML.
Sure.
There we go. It created a property for the infotainment system for whatever reason. I'm guessing something broke on the back end, but we'll just run with it. And as we see, we have all the satisfaction going on. And I guess we can put this on a table. Reference table, scope it, columns and satisfied by. So we can see that the specific systems that will satisfy these requirements.
So what is it doing in order to correlate the requirements to the block? Is it looking for certain keywords? Or?
It's kind of just doing its own thing. I gave it the definition of what a satisfy relationship should be, and then it's doing its magic on the back end.
It's awesome. Have you put together any type of a list yet as far as all the functions that you're including in it?
So far we can do requirements, use cases, blocks, activities, terms, interfaces. And when I say interface, that's connectors, and then signals, ports, interface blocks, state machines, value properties, test cases, and packages. And then in terms of relationships, right now we can understand refine, composition, satisfy, verify, derive, control flows, allocate, associations. And I think that covers a lot of it.
Okay. Yeah, that's great. It's a great list.
So we've made some blocks. So it's searching by name and class. So a term is the same class as a block, and they're both a type of class. So there's a small issue where I need to make this a little better, and I'm going to do this one last time. It composed the electric vehicle system by terms,
Okay, gotcha.
which is terrible
Good
because
to-
the API doesn't search by stereotype, which is
Sure.
rough.
Right. Sure, you can tweak the code on the back end.
Yeah, that's the plan. All right, there we go. Got this infotainment system property again. Created all the satisfy relationships. Let's look at this table again. There we go, that's better. And again, one of the issues with the search is it also is a base class of class.
Right.
So it found that and satisfied it to itself. Luckily, we can find that and hopefully replace that out. There we go. And that's how we do it.
Very nice. Yeah, I like
Yeah.
it. Yeah, that's awesome, Tony.
Yeah, in some cases, again, this is why the human is needed. In some cases, although I believe we should have a braking system right there, it did not create that relationship.
Okay.
Or that could have been because the code failed on the back end.
Yeah, that's awesome. I mean, I see a lot of efficiency gains here. So, it's definitely a work in progress, and it's coming along very nicely. So I'm impressed with what you have.
Right. Definitely by year's end, I should be able to create a complete system model without errors and full traceability. Definitely.
Right. Awesome. One follow-up question I have for some of this is, do you have plans for SysML version 2 and how something like this could complement a model in SysML version 2?
Yes, so absolutely. I've been playing around with it on the side, and luckily ChatGPT is already well versed in SysML v2. So that's not an issue on the training side, and it really understands truly what every element is, and I don't need to tell it to do anything because all the rules are pretty well written out in the specification. So luckily in the future, the textual notation versus the graphical notation. So definitely in the future, this will be a lot easier to develop these models and to code up tools to use AI, to use a large language model to generate a V2 model, because you can just, the LLM will automatically generate that text, which you can just paste into something, as opposed to what I'm doing now on the tool that's on the screen. I'm sending an element in, converting it using the Cameo API to convert it to JSON, passing that in with the prompt, returning JSON back, and then taking those elements and using the Open API to build out the model elements. So hopefully skipping the Open API, Cameo's Open API for the most part, will ease this whole process along.
Okay.
Yeah, so I'm definitely looking forward to that when we get our hands on, whatever the next release of this tool will be with the V2 capabilities. I'm definitely looking forward to rebuilding this for that tool.
Yeah, that's awesome. I think the sky is going to be the limit with what is possible with SysML version 2 coming out. And I know you're going to be able to take what you have here and use it in a way that's going to really accelerate the timeline of creating SysML models. So very, very impressive, Tony. I'm looking forward to see how you continue to develop this in the future. Let's say someone wants to get their hands on your plugin that you've created. Is this currently available to the public? Is it still in the works where you have maybe a beta release that you're planning? How can people get a hold of it and try it out?
Nobody can get a hold of it quite yet. I have a few more things to add to the plugin before I would consider it ready for release. After that, they just have to contact me directly and we can potentially work something out.
Okay.
So we don't have a good grasp on pricing yet.
Sure.
But yeah, contact me directly and we can talk. Or if you would like a beta release, just to play around with it.
Okay. Yeah, I know a few people that are interested in getting their hands on a beta release. So if you need anyone to help do any beta testing, there's quite a few people out there who would be interested in doing that. So when you say contact you directly, do you have an email address you'd like people to contact you at?
Yeah, it's tsukhwani@belkin.com.
Okay, tsukhwani@belkin.com. That sounds great. Well, I really appreciate your time today, Tony. I think everyone will be very interested to see how you continue to, add to this because it has so much capability already and so much potential. So thank you so much for giving us this little preview into what you're working on here. I think it's fantastic.
Thank you, Brian. Really appreciate it. Thank you for having me on your show.
Absolutely.